Hi everyone. In this short session, I like to talk about one of the key challenge which was faced in the context of cloud-based data lake solutions today. As you all know, in this today's digital and with an acceleration given by COVID, as well, there is an increased focus for enterprises to adapt into a data lake on cloud. But apparently, all these data lakes are typically defined on top of cloud object storage solutions like S3 or GCS or Azure Cloud Storage or so. Now that while that brings several benefits, one of the challenge would be that you may not really able to do any updates or deletes. So whenever there are changes coming from your data set, which includes updates or deletes to records which were inserted in the past, or either yesterday or last week or so, you are ending up doing a complete rewrite. You would amplify the entire writes, and you would anyway again create another larger data set and dump it in S3. So which this means that your ETL workload would be heavier, and the cost always matters when it comes to the cloud. So this is where essentially Apache Hudi comes into play. So, if you take a context from your typical on-premise warehouses or databases or so, where you have created consolidation of data, in those cases, typically we create an intermediate stage layer where we do any kind of updates, inserts, and ensure these data sets are refreshed for those changes. So this we couldn't able to do it on the cloud storage. Now Apache Hudi brings a solution which could minimize the overall workload time for an ETL and as well as ensure these updates and deletes can be carried out. Now if you take another critical requirement comes for these updates deletes to be done is from the context of private regulations, privacy regulations like GDPR, CCPA also. In these contexts, there is a necessary that you may have to do deletes on your data when the consent given by the customer is revoked. Then in those cases, we have to do a deletion of your data. So all this makes a context and a need for a solution. So Uber came up with this solution of Apache Hudi some time back, wherein they had a very specific challenge, which this Apache Hudi is able to solve it. In their context, they have several trip data comes from different trips, which their car taxi does. They have to do this trip data would have changes reflecting over the records from the past. It may be the records from yesterday or last week or last month or last year or so. Now these changes requires to be reflected onto their consolidated warehouses or databases or so. In their operational database, which was typically put up on top of Apache HBase, which was holding around 120 terabyte of data, they may have to do these updates of changes which may span around 100 GB of data. And to update 100 GB of data on top of this terabyte of data in HBase, it typically takes around 6 to 8 hours of ETL time. So they came up with Hudi, and with Hudi they able to drastically minimize the ETL overall time. So what is Hudi? Right, so Hudi is essentially a storage abstraction format. It is just an abstraction format in a way how you write it, right? So it is typically a library which provides this storage abstraction format, and that can be integrated to your query engines such as Spark or Presto or Hive. so that whenever it gathers the data, it represents or it abstracts that format so in such a way that you could simulate inserts, updates, or upserts in that data set. This is typically done using snapshot views which it creates, as well as a certain log which you could be able to create over the timeline of these changes of data. And this would help out in ensuring an abstraction which is created that would help out to minimize the overall ETL workload. And this is also very useful in a Lambda architectural scenarios where you have near real time data as well as historical data which needs to be served and merged and served in a near real time back to your consumers. So this is also a place where Hudi can really play a role. Hudi supports two different storage formats. One is copy on write and another is merge on read. Right, so copy on write is typically leveraged wherever you use heavy reads like ETL workloads. Right, so it would provide two kind of views. One is read optimized snapshot view. The other is incremental view, wherein the changes are constantly reflected on the incremental view. And this incremental views can be used for triggering any kind of real-time pipelines using that. The second format is merge on reads. And this merge on read is typically used in a case where Lambda architecture comes into play. And it supports three kind of views. Along with the read optimize and incremental, it also provides real-time view. That's a brief overview of Apache Hudi. Hope it helped. Thank you.